Okay, so the question says circumference of the base of the cylinder is 88 centimeter and height of the cylinder is 42. Find the volume. So clearly we need to have the formula of the volume. Before that, he has not given the radius, so we need to find out the radius. He says circumference of the base of the cylinder is 88 centimeter. Base of a cylinder is always circular. So circumference is nothing but circumference of a circle. So circumference of a circle is nothing but 2 pi r. So this 2 pi r value is given out to be 88 centimeter. So if we use this, we know the pi value as 22 by 7. So r can be 88 into 7 divided by 2. If we solve this, r value comes out to be 2 into 22. So r value comes out to be 14 centimeters. And that is the radius of the base of the cylinder is. Then he says height of the cylinder is already given to be 42 centimeter. Then he wants us to calculate the volume. So volume of the cone is always defined as pi r square h. So we need to put the values. So pi value is 22 by 7. Radius value we just calculated to be 14. So that's 14 square into 42. So we need to solve this equation. This is 22 by 7 into 196 is the perfect square of 14 into 42. So this 7 can cut this 42, 7 6 is 42. So if we solve these numbers and multiply, the ultimate volume comes out to be 25,872 meter cube, rather 7 centimeter cube, because the dimensions are in centimeter. So that becomes the right answer. Option available in option number the 25,872. So this is option available in option number A. That becomes the right answer. Now, three cubes of copper, each with the edge of 6, 8, and 10 centimeters respectively, are melted to form a single cube. Then find the diagonal of the new cube. So clearly, when the cubes formed, when these three cubes are melted, that means their volume is added together and a single cube is created. So the volume of collectively of these three cubes will be equal to the volume of that very cube. And if the volume of that very cube is single cube is known, then from the volume we can find out the side, and from the side we can find out the diagonal of that new cube. So first of all, we need to find out the sum of the volume of all these cubes. So volume of a cube is given by side cube. So we have got three sides, 6, 8, and 10. So let us find out the individual sum of the volume. So sum of the volumes is going to be 6 cube plus 8 cube plus 10 cube. This will be the sum of the volumes. So if we solve this further, this comes out to be 1728 ultimately. Okay, that is the 1728 centimeter cube is the volume of that single cube. Now he says diagonal of the new cube is to find out. For finding out the diagonal, we need to find out the side first. So side of a cube is always given by cube root of the volume. So volume we already have as 1728. So it's going to be cube root of 1728. Cube root of 1728 is nothing but 12 centimeters. So this is the side of that cube. Now he wants us to calculate the diagonal. Diagonal of a cube is given by side root 3. This is how the diagonal formula of a cube looks like, side root 3. So we can calculate. So we have got the side as 12. So side is going to be 12 root 3. Because the values are given in decimals, so we need to find out 12 into the under root 3 value is 1.73. 12 into 1.73. If we multiply this together, we're going to reach to 20.8 centimeter as the diagonal of this new single cube. 20.8 centimeter. It is available in option number B, so becomes the right answer for us. Now, in the next question, he says the circumference of the base of a right circular cylinder is 13.2 meter and sum of its radius and height is 3 meter. So what is he saying? Circumference of the base of the right circular cylinder. So obviously the base of the cylinder is nothing but a circle. So the circumference of this is given. So circumference of a circle is always 2 pi r. So this 2 pi r is given equal to 13.2. So from here, we can obviously calculate the radius value to be 13.2 divided by 2 pi. So if we put the value of pi, it is going to be 13.2 divided by 2 into 22 by 7. So 7 goes up. If we solve this, this comes out to be 2.1 meter. So the radius of the particular cylinder is 2.1 meter. Then he says The sum of its radius and height is 3 meters. So that's the radius plus height is actually 3 meter. That's what he has said. That's what he has said. Now, he wants us to calculate the total surface area. Radius we have already calculated to be 2.5, 2.1 meter. Total surface area. So TSA, that is total surface area of a cylinder, is given by 2 pi r h plus r. So without having to know the height value, we can calculate the particular value of the, we can calculate the particular value of the TSA. So it's going to be 2 into 22 by 7 into r value is 3. H plus r he has already given to us as h plus r he has already given to us as 3. So it's again going to be 3 inside. Okay. 2.1 was the radius, rather 2.1 into 3. If you solve this further, this comes out to be 39.6 meter cube. So that becomes the total surface area, 39.6 meter cube, and the radius was 2.1. So let's see where it matches. It matches with option number C. So it becomes the right answer from there. Now you say 66 centimeter cube of silver is drawn into a wire of 1 mm diameter. So the diameter of the wire is 1 mm, and see the volume is given in centimeter, so we can convert this into centimeter. 1 mm is nothing but half of a centimeter. Okay, 1 mm is nothing but half of a centimeter. Sorry, 1 mm is equal to 1 by 10 of a centimeter. So the diameter is 1 mm, so radius will be 1 by 2 mm. So radius will be simply 1 by 2 of 1 by 10 centimeter, that is nothing but 1 by 2, 20 centimeters. So the radius of that wire that has to be formed is 1 by 20 centimeter. Then he wants us to calculate the length of the wire. So clearly that will be in the form of a cylinder. The wire will be particularly in the form of cylinder, whose volume can be found out as, volume of that can be found out as pi r square L, where L is the length of the wire. Okay, this is how it can be found out. This L is nothing but treated as the height of the cylinder, because wire is horizontal, so that height becomes the length. So that's why we are saying pi r square L. That will be the volume of that particular wire that is to be melted, that is to be created, and this volume is given as 66 centimeter cube. Now we can put the values. So we have got L, we can generate the expression for L directly. That is going to be 66 divided by pi r square. Okay, which will be nothing but 66 divided by pi value is 22 into r square into 7 will go up. So if we put down the value of r here as well, it's going to be length is equal to 66 into 400 into 7 divided by 22, which gives us the final value as 8400 centimeter as the length of the wire. But he has given all the options in meter, so we need to convert this 8400 centimeter into meter. 1 meter is equal to 100 centimeter. So clearly 8400 centimeter is going to be 8400 divided by 100, which is 84 meter. So that is the length of the wire, 84 meter. It's available in option number B. Now he says length, breadth and height of a cuboid are in ratio 1, 2 and 3. Length, breadth and height of a cuboid are in ratio 1, ratio 3. So we'll have to assume the length, breadth and height first. So let the length of the cuboid is L, and let the breadth of the cuboid is 2L, and let the height of the cuboid is 3L. Okay, so we have assumed that. Now he's saying if they are increased by 100%, 200% and 200% respectively. So this L has been increased by 100%. Whenever something is increased by 100%, it actually becomes double of it. Okay, similarly the breadth has been increased by 200%. Whenever something is increased by 200%, that 200% is added to it, so it actually become 3 times. So the 200% is increased by it, so it becomes 3 times, so it becomes 6L, 2L into 3. Similarly the height has been increased by 200%. Again, something when increased by 200% actually become 300%, that is 3 times, so 3L also becomes 9L. So these are the new dimensions, and these are the older dimensions. So he is wanting us to calculate, then compared to the original volume, the increase in the volume of this cuboid. So let us find out the original volume. Original volume is going to be L into B into H, which is nothing but L into 2L into 3L, which makes it equal to 6L cube. This is the original volume. Then let us find out the new volume. New volume is going to be 2L into 6L into 9L. If we are multiplying them together, this is 12 9s of 108, 108 L cube. So this is what is 6L cube, another one is 100 L cube. So we need to find out how much times it has increased. So we can, so first of all, we need to subtract this because this is the new volume, this is the older volume. He wants us to find out then compared to the original volume, the increase in the volume. So increase in the volume, we need to find out in terms of time. So first of all, we need to subtract. What is the increase in the volume? Increase in the volume is 108 minus 6, that is nothing but 102 liter, 102 L cube. This is the increase in the volume. Now this increase in the volume as compared to the original volume is how many times? So we can say 102 is how many times of 6? 102 is how many times of 6 can be found out by 102 divided by 6? That is nothing but 17 times. So it has been increased by 17 times. So option C is right. Then he says the edge of the cuboid are in the ratio 1 is to 2 is to 3. Its surface area is 88 centimeters square. What will be the volume of the cuboid? So let us assume let us assume the sides first. So he has said that edges are in the ratio 1 is to 3, 2 is to 3. So let's say the length is x, let's say the breadth is 2x, and let's say uh, the height is 3x. So these are the three dimensions that we have assumed, L, B, and H. Now he says the surface area is 88 centimeters square. So we'll generate a formula for surface area, put the values and make it equal to 88. So the surface area of a cuboid is given by cuboid is given by twice of LB plus BH plus HL. So let us put the value. Twice of L value is x into 2x plus BH, so it's 2x into 3x plus HL, so it's 3x into x. Okay, and this is what is equal to, he has said, 88 centimeters square. So let us multiply together. It's going to be 2 into 2x square plus 6x square plus 3x square. This is what is equal to 88 centimeters square. If we solve this equation further, we're going to get reach to x square value as 4, which gives us x value as 2. So with x value of 2, we can easily find out all the dimensions. Okay, so the L becomes 2, B becomes 4, and H becomes 6. And the unit of them, all of them is simply centimeter, 2 centimeter, 4 centimeter, and 6 centimeter. The dimension has come. Now he wants us to calculate the volume of the cube. So volume of the cube can be easily find out. Volume of the cuboid rather can be easily find out by L into B into H. If we multiply them together, this is going to be 2 into 4 into 6. That is nothing but 8 6 ja 48 centimeter cube. So that is the right answer, 48 centimeter cube. It is available in option number D. So that is right answer. Now, the vertical height of a conical tent is 2 by 3 meter. So let's make a conical tent out of it. Okay, this is the conical tent. He says this very height is 2 by 3 meter. If we convert this into simple fraction, this becomes 3 4 12 plus 2. 14 by 3 meters. This is the vertical height, and the diameter of its base is 6 meters. So if the diameter is 6 meter, so the radius will be obviously just half of it, that is 3 meter. Now it can accommodate 11 person. Find the average air space allowed per head. So volume of air inside will be nothing but the volume of this particular cone. Okay, so we need to find out first of all the volume of this particular cone. Okay, we have got all the values with us. So let us find out the volume of the cone. Okay, so volume of the cone can be given by the formula called as 1 by 3 pi r square h. This is the formula of the cone. Let's put the value. So it's going to be 1 by 3. Pi is 22 by 7 into r value is 3 square into h value is 14 by 3. So we need to solve this particular expression. If we solve this, this is coming out to be 44 meter cube. So that is the volume of the conical tent is. So volume of tent is nothing but the volume of air also inside the tent, is nothing but the volume of air also inside the tent. So this much air is available, and a total of 11% can consume this air. So what is the average air that can be consumed by per person is, so air per person can be calculated by total volume of the air, that is 44, divided by how many persons are there, that is 11. So 11 by 44 by 11 gives you 4 meter cube. So that much volume can be taken by one person on an average. So that is the right answer, available in option number C. Now he says a cylindrical tank of diameter 35 centimeter is full of water. If 11 liters of water is taken out from the tank, find the drop in the water level, that is height drop in the tank. So we have got a cylindrical tank like this, and it is full of water, he says. So water is full till here, let's say. Okay, the water is full till here, and the cylindrical tank of diameter 35 centimeters. So if the diameter is 35, so clearly the radius is going to be 35 by 2, that is 17.5 meter. Okay, is is full of water, so it is full of its capacity. 11 liters of water is taken out, so 11-liter water has been taken out. So let us first convert this 11 liter into meter cube. Okay, by a conversion factor, 1 liter is equal to 1000 centimeter cube. So 11 liter is equal to 11 into 1000 centimeter cube. So that is what is the actual volume that has been removed. So 11 into 1000 centimeter cube of volume has been removed. So obviously the amount of volume removed will be actually the amount of the water taken out from the cylinder in the shape of cylinder only. Okay, so we need to find out the, let's say if the 11 liter is taken out, let's say the height goes from here to here. So let's say this is that particular part of the tank where the height has grown down. So this is again in the shape of a cylinder only. So the volume can be calculated by the shape of cylinder only. So volume of a cylinder that will be used here. Volume of a cylinder is given by Volume of a cylinder is given by pi r square h. So where this h is the total height, here the height will be that particular height or that particular drop of the level. So it has to be pi into r value is 17.5, pi r square into h value we have to calculate. And this is happening because 11 liter of water has been drawn out, whose volume is actually 11,000 centimeter cube. So using this particular expression, we can easily find out the value of h. So let us put the value. So h is going to be equal to 11,000 divided by 22 into 7 goes up, and this 17.5 square comes down. It has to be 17.5 square like this. So clearly we need to solve this particular equation. Okay, so h value is actually coming out to be ultimately 80 by 7, that is nothing but 11.428 centimeters. So that is the height value, 11.428 centimeter. That will be the drop in the water level. So that is available in option number C. Now, a copper rod of 1 centimeter diameter and 8 centimeter length is drawn into a wire of uniform diameter and 18-meter length. Okay, there was a copper rod, 1 centimeter was the diameter of it. Okay, and 8 centimeter was the length of it. It has been drawn into a wire of uniform diameter and 18-meter length. Okay, so wire is of a form of a cylinder. So what is the volume of that cylinder? The volume of a cylinder is always given by pi r square h. Here the h will be treated as the length of the wire because it will be horizontal. Okay, so we can clearly write pi r square into height of the wire, or the length of the wire rather, has been given as 18 meter. Because all the options are in centimeter, so let us convert this meter into centimeter. 1 meter is equal to 100 centimeter. So 18 meter will be simply 1800 centimeter. This will be equal to, see where from this wire has been made. This very wire has been made from the another cylinder who had got a diameter of 1 centimeter and who had got the length or the height as 8 centimeter. So this has come from another particular wire of the cylinder shaped into pi, whose volume is again pi r square h. Pi is as it is. Radius value, see the diameter is 1 centimeter, so radius value will be 1 by 2 centimeter. So it will be 1 by 2 square into height value is given as 8. So this is how the things have been defined. Now we are supposed to solve for r square. Obviously pi and pi gets cancelled. R square can be found out as 2 by 1800. Can be found out as 2 by 1800, where r square gives us r square value is 1 by 900, which is nothing but 1 by 30 centimeters. So that is 1 by 900 is the r square value. So r value is simply 1 by 30 centimeters. So that becomes the right answer. 1 by 30 centimeter is the value of the radius that is available in option number D, becomes the right answer. Now he says a beam of 9 meter long, 22.5 centimeter thick and 20 centimeter high is made up from iron which weighs 50 kg per meter cube. This is what is the statement given. Okay, a beam of 9 meter long, 9 meter long, 22.5 centimeter thick, of 20 and 20 centimeter high is made up. Okay, so obviously the things have been recasted or remelted and redrawn. So we have to consider the same consideration and then we can solve the question like that. So what he says is 9 meter long is the beam length. So let us notice all that. So clearly there has been a recasting, and he says the iron which weighs 50 kg per meter cube. So 1 meter cubes has got a weight of 50 kg. So what we'll try to find is that what is the weight, what is the volume of this very structure that is there with us. Okay, this very structure has got a length and a breadth and a height. So clearly this is a structure of a cuboid. Okay, and cuboid has got a volume of L into B into H. So if we use this, length is 9 meters. See, everything is just convert has is just required to be converted into meter, because the 1 meter cube is equal to 50 kg. That is the particular ratio. So first dimension is length is 9, that is already in meter, into breadth value is 22.5 centimeter, needed to be converted into meter by dividing it by 100. Why so? Because 1 meter has got 100 centimeter. So 1 centimeter will be 1 by 100 meter. Into height value is given as 20, so it has to be 20 divided by 100 meter. Okay, and this value particular volume has to be equal to the other thing that is given as centimeter thick and 20 centimeter height, that is also mentioned. So this is what we are supposed to found first. Okay, if we solve this particular value, this comes out to be 0.405 meter cube. Okay, so this much is the volume of that particular beam. And we come back to our original conversion factor. We said for 1 meter cube the weight is 50 kg. So for 0.405 meter cube, how much will be the weight? The weight will be 0.405 into 1000 into rather 50 kg. That is equal to 20.25 of kg. So that is going to the weight of this particular beam that you're going to make. Okay, 20.25 kg. Option A is the right answer. Now it says an iron cube of side 10 centimeter is hammered into a rectangular sheet of thickness 0.5 centimeter. Okay, there was an iron cube of the side as 10 centimeter has been hammered. So when it is hammered, it has actually become a cuboid. That's why it has got a thickness. So the volume of uh, the hammered cuboid, we can write it like this: volume of the completely hammered cuboidal shape cuboidal sheet, volume of the completely hammered cuboidal sheet is actually equal to the volume of the initial cube. This is what we can think. Now, he says the thickness is 0.5 centimeter if the sides of the sheet are in ratio 1 is to 5. So let's say that cuboid has a length of x meter. So the breadth will be 1 is to 5. This is the ratio. The breadth will be 5x meter, rather centimeter. Let's take this in centimeter. So length is x centimeter, breadth is 5x centimeter. These are the dimensions. Now volume of the hammered cuboid we need to calculate. So after the cuboid has been hammered, so the length has become x, the breadth has become 5x, and the thickness is also already mentioned is zero point 0.5. So length into breadth into height, that is the formula for the volume of a cuboid that has been used here, is equal to volume of the cube. Volume of the cube is always given by side cube. Side value is 10, so it is going to be 10 cube. So we need to solve for x. So here x square comes out to be 10 into 10 into 10 is nothing but 1000 divided by 0.5 into 5. So if we solve this further, x square comes out to be 400, which gives us x value as 20 centimeter. Okay. So if one of the side is 20 centimeter, that is length of this cuboid has come out to be 20 centimeter. So the breadth of the cuboid will be x. They were in the ratio x and 5x. So breadth of the cuboid will be nothing but 20 into 5, that is 100 centimeters. So that is the breadth, and the length, that is 20 and 100 centimeter. It is available in option number D, so becomes the right answer there. Now he says volume of a cuboid is twice the volume of a cube. Okay, volume of the cuboid is twice the volume of a cube. Okay, if the dimension of the cuboid be 9 into 8 into 6 centimeter, then find the total surface area of the cube. So clearly, first of all, we'll find out the volume of the cube by with the help of a connection with the volume of cuboid, and then while finding out the volume of the cuboid, we'll be able to find the volume of the cube. We'll find out the surface area. So first of all, let's look at the connection. He says volume of the cuboid, which is nothing but L into B into H, he says is equal to twice the volume of a cube. So twice the volume of a cube, which is value of the cube is always given by side cube. Okay, this is what is the connection. And he has given all the dimensions of the cuboid. So it's going to be 9 into 8 into 6 is going to be equal to twice of volume of the cube. So twice of volume of the cube, the twice of side cube of the volume. So 9 into 8 into 6, that's what it is. So side cube comes out to be 9 into 8 into 6 divided by 2, which is nothing but uh, 216 centimeter cube. So if the side cube is 216 centimeter cube, then the side value will be simply cube root. Side value is simply cube root of 216 centimeter. That is nothing but 6 centimeter. Okay, so this is what is the side of the cube achieved. Now he wants us to find the total surface area of the cube. So TSA of the cube is related by a formula called as the TSA of the cube is given by 6 into a square. Okay, so let us put the value of side. The side value is 6. A is side only. 6 into 6 square, that is nothing but 6 into 36, which is 216 centimeter square. So that is the total surface area of the cube available, 216 centimeter square. Now he says if the volume of a sphere is divided by its surface area, the result is 27. So what he's saying is volume of the sphere divided by surface area of the sphere. Surface area of the sphere, he says the result is 27. So we have to know the formula of volume and surface area. Volume of the sphere is given by 4 by 3 pi r square, 4 by 3 pi r cube, divided by surface area of the sphere is given by 4 pi r square. Okay, and this has to be equal to 27. So we can cut down many things here itself. 4 gets cancelled, pi gets cancelled, both powers of r square are gone, only one power is left out over there. So it becomes r by 3 is equal to 27. So the radius value comes out to be 27 into 3, that is 81 centimeter. This is what is the radius value comes out to be. That's what he had asked. Find the radius of the sphere. It is 81 centimeter, available in option number A. Then he says a solid in the form of a cuboid, 4 centimeter cross 3 centimeter cross 2 centimeter, its volume will be what? Okay, so this is going to be like this, that volume solid in the form of cuboid. So let's find out what is the volume of a cuboid is. Volume of a cuboid is simply going to be L into B into H. Okay, so which is 4 cross 3 cross 2. Okay, we wants us to calculate the volume, so let us multiply these numbers. 4 cross 3 cross 2, that is going to be 4 3 12 2 24 meter, 24 centimeter cube. So that is the right volume which is available in option number D. It becomes the right answer. He says if the radius of a right circular cylinder is decreased by 50% and its height is increased by 60%, okay, its new volume will be decreased by what? So we will segregate like this. Let's say the original one, let's say we'll assume some value so that the things become easy. Let the radius is 10 centimeter and the height is also 10 centimeter. Let us assume some arbitrary any easy value. Okay, so radius is 10 centimeter, height is 10 centimeter. We are talking about the cylinder here. Okay, we are talking about the cylinder here. So the volume of a cylinder is nothing but volume of a cylinder is given by pi r square h. Okay, so how much it is? Pi into radius is 10, so it's 10 square, into h is again 10, so it becomes 100 pi. Okay, 100 pi centimeter cube. This is the first volume. Then he says next time the radius is decreased by 50%, so the new radius will be Rn will be, if something is out of something 50% is reduced, then 50% is only left out. So from 10, if 50%, that is 5, is removed, only 5 will be left out. So 5 centimeter will be the new radius. And what about new height? New height is, he's saying the height is increased by 60%. 60% of 10 is 6. So it is increased by 6. So it means it becomes 16 centimeters. So these are the new radius and new height. Let us find out new volume. New volume will be again pi r n square into hn, that is new radius and new height, is equal to pi into new radius is 5, so it's going to be 5 square into new height is 16. If we solve this, this becomes 25 into 16, that is nothing but 400 pi centimeter cube. So original volume is 100 pi, the new volume is 400 pi. He wants us to calculate its volume will be decreased by, okay, its volume will be decreased by. So clearly we can say uh, 25. Okay, this is 25 into 16. 10 square into 100 1000 pi. This is coming out 400 pi. 1000 pi to 400 pi, there is a decrement of 600 pi. Okay, and 600 pi of 1000 pi is 60%. So clearly the volume has been decreased by 60%, which is available in option number D, becomes the right answer. Now the question says a swimming pool is 9 meter wide, 12 meter long, is 1 meter deep. on the shallow side and 4 meter deep on the deeper side. So swimming pool looks like this. Okay, this is how it goes. So on the shallow side it is 4 meter deep. On the on the on the deeper side it is 4 meter deep, and on the shallow side it is 1 meter deep. Length and breadth are given. Okay, so length and breadth are also given as 9 into 12. Okay, so he wants us to calculate the volume. So volume of such shape where the height is varied is given by length into breadth into h1 plus h2 by 2. That is depth 1 plus depth 1, depth 2 by 2. This is how the volume of such shapes are given where the height is varied. So let's put down the values. Length value is 9, breadth value is 12 into height value. One height value is 1, then another is 4, 1 plus 4 by 2. Okay, which is the mean height actually. If you solve this further, this becomes 12 into 9 into 5 by 2, which is nothing but 270 meter cube. So that is the volume of this particular swimming pool. Is option A is the right answer. Now he says a hemispherical bowl of internal radius 9 centimeter contains a liquid. This liquid is to be filled into cylindrical shaped small bottles of diameter 3 centimeter and height 4 centimeter. How many such bottles will be needed to empty the ball? So clearly, first of all, we need to find out the volume of that particular liquid that is there in this hemispherical ball, and then that particular volume has to be transferred into different cylindrical shaped bottles. So that volume has to get divided by the volume of each such cylindrical bottle. That will give us the number. Okay, so let us quickly find out the volume of the hemisphere first. Volume of a hemisphere. Okay, because the shell is of ball is of hemispherical shape. Volume of the hemisphere is given by 2 by 3 pi r cube. So where is the ball? The radius of the hemispherical ball is nothing but 9. So it has to be 2 by 3 into pi into 9 cube. Okay, so we can leave it like that also, or we can, so that we can use it later on. So let's leave it like this only. Now let us find out the volume of each such cylindrical bottle in which the liquid is to be transformed. So cylindrical shaped volume of cylindrical shaped bottle. Volume of a cylinder is given by pi r square h. So let us put down the values. It's going to be pi into radius of that bottle is, see, diameter is given 3 centimeters, so the radius will be half of the diameter, so it will be 3 by 2 square into height of that bottle is given as 4 centimeters. So this is the volume of the bottle. So clearly the number of such bottles that can be emptied in with this liquid, that can be filled with liquids, will be volume of the hemisphere, divided by volume of cylindrical bottle. Okay, so let us put down the values. That is going to be 2 by 3 into pi into 9 cube multiplied by divided by pi into 3 by 2 square into 4. Okay, if you solve this further, few things get cut, pi and pi gets cancelled. Okay, so ultimately this is coming out to be, this particular ratio is coming out to be 54. Okay, the ultimate number that after solving it is coming out to be as 54. So that many number of bottles will be required. 54 is the right answer. Now he says how many iron rods, each of length 7 meter and diameter 2 centimeter, can be made out of 0.88 cubic meter of iron. So clearly 0.88 cubic meter is the volume of iron which has been used to create these iron rods of this dimension. So for that we need to find out the volume of each rod, and when we know the volume of each rod, then we can divide the total volume of the iron divided by the volume of each rod to give us the total number. So let's say the volume of the iron that is available with us is 0.88 meter cube. Okay, let us find out the volume of, let's say, the volume of each iron rod. Volume of a iron rod. See, a rod is going to be in the shape of a cylinder. So we'll have to use the formula of the volume of the cylinder, that is pi r square into h. Here the pi value is as it is, pi r value is the radius of the the rod. So diameter is given as 2 centimeters. So the radius will be treated as 1 centimeter. Here we are dealing in the which we are dealing in the meter itself. So we need to convert this to 1 centimeter into meter. 1 meter has got 100 centimeter. That means one particular centimeter has got 1 by 100 meter. So radius value will be 1 centimeter or 1 by 100 meter, and a square into height value is given as 7 meters. So we'll use it as 7 nd. So this will be the volume of each rod. Now the number of such rods that can be created, number of rods is simply volume of the total iron available with us divided by volume of each rod that we calculated. Let's put down the values. So it's going to be 0.88 divided by pi is 22 by 7 into 1 by 100 square into 7. So clearly we need to solve this equation. If we solve this, this number comes out to be 8800 divided by 22, which is nothing but 400. So we will be able to create 400 such iron rods. Option number B is the right answer. Now he says length of the longest rod that can be placed in a room 12-meter long, 9-meter broad, and 8-meter high is. So clearly the room is of a shape of a cuboidal. Okay, room is a shape of a cuboid like this. Okay, we can create the room like this. This is the shape of the room. And he's asking for the longest rod. So longest rod is always the diagonal of the cuboid. Okay, so we need to know the diagonal value of this cuboid, then only the longest rod will be the dimension the longest rod will come. So diagonal of a cuboid is given by under root of L square plus B square plus H square, that is the diagonal length. So it is given by under root of length value is 12, so 12 square, breadth value is 9, so 9 square, height value is 8, so 8 square. If we solve this further, this is going to be 100 under root of 144 plus 81 plus 64. If you solve this, this is coming out to be under root of 289, which is equal to 17 meters. So that is the length of the longest rod that can be kept inside this room. Value is called as 17 meter. Now he says a rectangular tank is 80-meter long and 25-meter broad. Water flows into it through a pipe whose cross section is 25 centimeter squares. Okay, so there's a pipe like that. Okay, the water is coming out of it. Okay, water is coming out of it. Okay, the cross sectional area of this particular pipe is given out to be 25 centimeters square. Then he says this has to fill a rectangular particular tank whose length is going to be 80-meter and whose breadth is going to be breadth like this, whose breadth is going to be okay, whose breadth is going to be 25-meter. Okay, water flows through it at the rate of 16 kilometer per hour. So the rate of the water that is there is 16 kilometer per hour. This is the speed. How much will the level of the water rise in the tank after 45 minutes? With this speed, if the water keeps on flowing, let's say the initial level of the water is this. So he's saying by how much meter the level will rise up because of this filling after 45 minutes. This is what is the question. Okay, so let us find out something. So first of all, all the dimensions are in minutes, or all the dimensions are in meter. So we need to convert our every dimension into meter. First of all, the speed is given as 16 kilometer per hour. So this speed can be converted into the actual speed. So speed is nothing but 16 into the kilometer per hour can be converted into meter per second by 5 by 18. So kilometer per hour is converted as 5 by 16 into 5 by 18. That is going to be 80 by 18 meter per second. This is going to be the 80 by 18 meter per second. Now, this is going to be the speed. Now, let us find out in 45 minutes what will be the length of the water column. So, in 45 minutes, if we talk about 45 minutes, in 45 minutes, length of the water column. Let's talk about this. Length of the water column will be how much? Okay, so we need to see the speed is 80 by 18 meter per second. Per second it is 80 by 18. How many seconds are there in 45 minutes? It's going to be 45 into 60. So in a second the it travels till 80 by 18. So in 45 into 60 second it will travel till 80 by 18 get multiplied with it. This much meter it will travel. So this will be the length of the water column. Whenever the length of the water column is multiplied by the cross sectional area, it actually becomes the volume. Okay, so we're going to use that only. So volume of water coming out from the pipe, volume of water from pipe in 45 minutes will become how much? Will become equal to length of the water column, length of the water column multiplied by cross sectional area of the pipe, cross sectional area of the pipe. Okay, so we have both the things. So length of the water column is nothing but 45 into 60 into 80 by 18 multiplied by cross-sectional area that is already given to us as 25 centimeter square. Let us convert that into 100. That is converted into meter square by dividing it by 100 and 100 for 2 centimeter squares. So it has to be 20, like this, meter square. So this is the particular volume of the water coming out from the pipe. Now, on the other side, we have the dimension of the tank. So let's say there will be a rise of h meter in the water tank because of this water flow. So clearly the water will be grown up in the shape of in the shape of a particular cuboid only. So cuboid has got a volume ratio of L into B into H. So L of the tank is 80, breadth of the tank is 25 into, let's say there is a rise of h meter. This particular rise is all because of the water coming out from the pipe, which is on the other side of the mathematical part. So in this way we can calculate our h. So let's cut down few things. 80 can cut 80 like this, okay, then 25 can cut 25 this. So h remains 60 into 60 divided by 18, 60 divided by 18 into 100 square. This is how it comes out to be, and into 45. So this is what is the final calculation. So clearly we can solve this equation. It comes out to be, as you say, 60 into 45. So we can cut down few things like that. Okay, if we solve this, 60 into 45, so 18 can cut 45 easily. So let us find out 60 into 45. 60 into 45 value is 2700 divided by 18 into 100 square. That is the next target. So 100 and 100. So zeros can be easily gone. So we can solve this further. This has come out to be 150 over 100 square. So which is nothing but 150 over 100 square. If we calculate, that comes out to be 0.015. 0.015 value is coming in meters. So clearly in centimeter, it has to be 1.5 centimeter. So that is the level rise that should happen. So the right answer should be option number E, which is 1.5 centimeter. That becomes the right answer, 1.5 centimeter. Now, in this question, he says, two spheres have their surface area in the ratio 9:16. Their volumes are in the ratio of what? So first of all, we need to see the surface area. Surface area of a sphere is given by 4 pi r square. So let's say the two surface two spheres have radius r1 and radius r2. So if we create the ratio surface area 1 divided by surface area 2, if you want to know, surface area 1 is nothing but 4 pi r1 square divided by surface area 2 is 4 pi r2 square. Okay, these are the two surface areas. They are being compared. Okay, he says this ratio is 9/16. Okay, if you solve this, 4 and 4 cancel, pi and pi cancel. So ultimately r1 by r2's whole square comes out to be 9/16, which ultimately gives us r1 by r2 value as under root of 9/16, which is 3/4. So this is the ratio of r1 and r2. He wants us to calculate the ratio of the volume. So V1 by V2, volume of a sphere is given by simply 4 by 3 pi r cube. So it is pi r1 cube, and this is 4 by 3 pi r2 cube. Okay, so 4 by 3 and pi gets cancelled. Ultimately, it is left out as r1 by r2's whole cube. We already know the r1 by r2 value. Let's put it here. So we're going to get to add 3 by 4's whole cube, which is nothing but 81 by 27 by 64. That should be the right answer. It has to be 27 by 64. It is available in option number B. So becomes the right answer there. Now he says a rectangular tank is 225 meter by 162 meter at the base. With this, what speed must the water flow through an aperture 60 centimeter by 45 centimeter, that a level may be raised by 20 centimeter in 5 hours. Okay, so these all things are given. So let us first assume the speed of the water. Let's say the speed of water is, let's say, x meter per hour. This is the speed of the water. Okay, then how much volume of the water will flow in 5 hours? So volume of water that will flow in 5 hours will be, okay. Okay, so it will be with the speed of x meter per hour. In an hour it goes x. So in 5 hours it will be clearly the rectangle, the dimension of the tank is given by 225 into 160. So it has to be L into B into height. Height is, he's saying, is height is to be raised by 20 centimeter. So that is the height. So let's put down all the values. So it's going to be length value is 225, breadth value is 162, and the height value to be risen is 20 centimeter. If that is to be converted into meter, so it has to be 20 by 100. That is nothing but 20 by 100 meter cube. So this is much is the volume to be risen in 5 hours. Okay, so if this is to be risen in 5 hours, then volume to be risen, volume of water to be risen in 1 hour will be simply this divides by 5. Okay, so you need to divide this by 5, so it comes out to be 45 into 162 divided by 5. That becomes equal to 9 into 162 centimeter cube. Okay, this much is the volume of water to be flowed in 1 hour only. Now let's see how much water is flowing. The water flown can be calculated by cross section of the pipe, cross section of the pipe or the aperture multiplied by length of the water column, cross section of the pipe multiplied by cross section area of the pipe multiplied by the rate. Okay, rate is x meter per hour. So this particular volume will be equal to, let's see the cross section. Cross section has got length and breadth, which has got 60 centimeter. So it is converted in meter as 60 by 100 into 45 centimeter, converted into meter is 45 by 100 into the rate is x meter per hour. This has to be get equal to our 9 into 162. So if we solve this, x value can be solved by these transfer from left hand side to right hand side, which comes out to be 5400 meter per hour. So this becomes the right answer. X value is 5400 meter per hour. It is available in option number C. So it becomes the right answer there. Now, in the next question, he says, if the area of the base of a cone, if the area of the base of the cone is 770 meters square. Okay, so the cone has got a base. The base of the cone is always circular. So that's what he talks about. The area of the base of the cone is 770 centimeter square. That is the circular area is 7 centimeters square, and the area of the curved surface is 814 centimeters square. So we can always compare them and get the values. So first of all, cone has got a base of a circle. He says the base area is 7 centimeter. That means the circle area is 7 centimeter. So by this we can calculate the value of r. R square is equal to 770 into 7 by 22. So R value will be nothing but under root 35 into 7, that is 7 root 5 centimeters. So this is what the radius value has come out. Now, he has given the area of the curved surface is 814 centimeter square. Curved surface area of a cone is given by pi r l. So this is given here is 814. So let us put down the values here. So it's going to be 22 by 7 into radius value is 7 root 5 into length value is unknowns, it is equal to 814. If we solve this further, the length value comes out to be 814 divided by 22 into root 5. If you solve this, it comes out to be 37 divided by root 5 centimeter. That is the value of the length. Okay, now we are supposed to find out the volume. The volume of the cone is given by 1 by 3 pi r square h. So clearly we need to know the value of h. For finding out the h, if you see the figure of a cone, this is how the cone looks like. This is what is the height value, this is what is the radius value, and this is what is the slant height value. So this height, this L square is always equal to h square plus r square, which gives us the h value as under root of L square minus r square. So we'll use this value, this particular expression of h to find out our h. In this case, we have got the L value, we have got the r value. So h value will be equal to under root of L square minus R square. So L value is 37 by root 5 whole square minus R value is 7 root 5 whole square. So this is what it is. So if we solve it, this comes out to be under root of 144 by 5, which is nothing but 12 by root 5. So that is the value of the height that we have calculated, 12 by root 5 centimeter. Now we can put this height value into the formula of the volume of the cone. If we do that, volume of the cone is given by 1 by 3 into pi, that is 22 by 7 into r square, that is 7 root 5 whole square, into h, that is nothing but 12 by root 5. If you solve this further, this ultimately comes out to be 616 root 5 centimeter cube. So that is the ultimate volume. Let's see where it is available. It is available in option number D, becomes the right answer. Now he says a solid sphere of radius 3 centimeter is melted and then cast into small spherical balls, each of diameter 0.6 centimeter. Find the number of balls thus obtained. Okay, so a solid sphere is melted, so its volume is to be converted into small spherical balls. Okay, they have a different radius. So he's asking for the total number of such balls that can be created. So clearly we are supposed to find out the volume of each particular ball there. Okay, so let us find out. So volume of the solid big volume of the big sphere can be calculated by volume of a sphere is given by 4 by 3 pi r cube. So let us put the values. It's going to be 4 by 3 into pi value is as it is to be used, pi into r value is given as 3. So 4 by 3 into pi into 3 cube. This is what is the value becomes. Now volume of the small spheres. Let us find out volume of the small sphere, that is 4 by 3 into pi again into, let's say, rb for big and r small for small, r is cube, and the small radius small cube value is given as zero point 0.3. So 4 by 3 into pi into zero point 0.3 whole cube, this is what it becomes. Okay, now these are the two volumes that we have. Now clearly he says how many number of such balls can be created. So number is always given by volume of the big sphere, volume of the big sphere divided by volume of the small sphere. This is what gives us the total number, volume of the small sphere. Let's put down the values. So volume of the big sphere is coming out to be 4 by 3, 4 by 3 into pi into 3 cube divided by 4 by 3 into pi into zero point 0.3 cube. So this is what we are supposed to solve. Obviously 4 by 3 pi and 4 by 3 pi can cancel. So we are ultimately left out with 27 divided by 0.027, which is nothing but 1000. So that is the right number. 1000 is the right answer. Okay, so the question says curved surface area of a cylinder is 528 square centimeter while its height is 8 centimeter. Find the volume of the cylinder. So we will equate each and everything one by one and then try to create the dimensions. So first of all, he says surface area, curved surface area of a cylinder is given by 528 centimeter square. What is the curved surface area? The formula for curved surface area of a cylinder is 2 pi rh. So clearly 2 pi rh is equal to 528 centimeter square, which can give us the value of r. R value is clearly 528 divided by 2 pi h. Okay, so we have got the h value as 8 centimeter itself, so we can keep down the values here. 528 divided by 2 into 22 by 7 into h value is 8. If we solve this further, this comes out to be 21 by 2, which is nothing but 10.5 centimeters. So that is the radius of the particular cylinder is there. Radius, he's wanting us to find out the cylinder. So volume of the cylinder. So volume of a cylinder is given by simply uh, pi r square h. This is the formula for volume of a cylinder. So let us put down the values. 22 by 7, r value is 10.5. So 10.5 square into height is already given as 8. So we need to solve this particular equation. If we solve this particular mathematical expression, the ultimate volume is coming out to be 2772 centimeter cube. So that is the right answer, 2772, which is available in option number B. Now, he says the ratio of the radius of two cylinders is 2 is to 3 and the ratio of their height is 5 is to 3. So let us assume the radius. So R1, let's say R1 is 2r and r2 is let's say 3r. Similarly, we can assume the heights also. Let's say the h1 is 5h and let's say the h2 is 3h. So we have assumed the radius and heights as that. Find the ratio of their volume. So we need to find out the volume 1 divided by volume 2. These are the volumes of a cylinder. So volume of a cylinder is always given by pi r square h. So we're going to have to use this particular formula for finding out the volume. So volume number 1 will be pi into r square, that is r1 square h1, and volume number 2 will be pi into r2 square h2. Let's see what are those values. It's going to be pi into r1 value is 2r whole square into h1 value is 5h divided by pi into r2 value is 3r, so 3r whole square into h value is 3h. So these are the values. Now let's just try to find it out. Pi and pi gets cancelled, so we are ultimately left out with 20 by 27. So that is the volume ratio of the two cylinders, 20 by 27. It is available in option number C, so becomes the right answer. Then he says height and base radius of a solid cylinder are 14 and 4. So height and the radius of a cylinder are already given to us. Okay, it is melted and recasted into a solid cone of the same base radius as that of the cylinder, what will be the height of the cone? So radius of the earlier cone is equal to radius of the new cone, radius of the new cylinder. So we can treat this as only r, uh, which value is given as 4 meter, and height of the first cone is different from height of the first cylinder is different from height of the second cylinder. So these two will be treated as h1 and h2, where h1 value is already given to us as 14 meters. So let us apply this. He says obviously the first has been melted and recast into the another one, so the volumes remain same. Okay, so the volume remains same. So clearly we can find out the volume of the first cylinder is going to be volume of the cylinder, height and base radius of solid cylinder. So this is a cylinder, so we need to apply the formula. So it's given as pi r square h1 is equal to pi r square h2, because the radius are same, so we don't need to keep those radius as different. So it is going to be pi and pi gets cancelled, so we are left out with r value is 4. So 4 square so 4 square into h1 value is 14 is equal to r square. R value is again 4, so 4 square into h2. So this is what we are supposed to find out. So let us find it out. So height value comes out to be, by using this, we can say the volume of the cylinder and that remains same. But the problem here is the next one is a cone. The next shape is of a cone. So we can say the volume of the cylinder is equal to volume of the cone. So the first one was the cylinder, so we have to apply the cylinder volume, which is pi r square h1. Next one is a cone, so we'll have to have a 1 by 3 here, 1 by 3 pi r square h2. So everywhere this was a 1 by 3 here. So clearly if we solve this, then this gives us h2 value as 14 into 3. Rest of the things are getting cancelled, so which is equal to 42 meter. That is the height of the new cone that will be recasted. Answer is 42 meter. Now he says 1 cubic meter piece of a copper is melted and recast into a square cross section bar of 36 meter long. Okay, so there is a cross sectional bar. This is a bar and whose cross sectional area like this. This particular cross section has been given as this particular section cross section area. We have to assume, and the length of this bar is given as 36 meter. It's like that. Okay, so this way we can find out the volume obviously. Okay, and further he says an exact cube is cut off from this bar. If 1 cubic meter of copper costs this much, then the cost to the cube is. So clearly we'll have to find out the volume of that particular exact cube that is to be cut off. Okay, so first of all, let us try to find out the volume of this particular metal copper piece. For that, let's say the this so the cross section is a square. So let's say the side of this cross section, let's say the side of this cross sectional area, which is in the form of a square, is, let's say, a. So volume of this particular bar will be, volume of a bar is always calculated as cross sectional area multiplied by the length or the height. In this case, it is length. So cross-sectional area of a square will be a square into length value is 36. So a square into 36, and this is exactly equal to 1 cubic meter, because that is the volume of the ultimate bar is. So from here, we can find out our a value. So a square is going to be 1 over 36. So a is going to be 1 over 6 meters. So this is the side of the cross-section has come. Okay, now he's saying the exact 1 meter, one exact cube is to be cut off. So if exact cube is to be cut off, so clearly the side of that particular cube will be 1 by 6 only, because the cross section is in the form of 1 by 6 into 1 by 6 only. So the volume of that cube will be how much? Volume of that cube that has been cut will be 1 by 6 whole cube. That is nothing but 1 by 216 meter cube. That will be the volume of that particular cube that will be cut out. Then he says cost of, then he mentions cost of 1 meter cube of copper is 108. So we need to find out cost of this cube. So 1 meter cube costs rupees 108 rupees. So we have got 1 by 216 meter cube. So 1 by 216 meter cube will cost how much? It will cost 1 by 216 multiplied by 108. That is nothing but 0.5 of a rupee, which is equal to exactly 50 paise. Okay, 0.5 of a rupee or 50 paise. Let's see where it is available. It is available in option number B, becomes the right answer. Now he says, if the radius of a sphere is increased by 2 centimeter, then its surface area increases by 352 centimeter square. Find the radius of the original sphere. So let's say the original sphere has got a radius of r. Okay, so what is the let's say the what is going to be the surface area of a radius? Surface area of radius is given by 4 pi r square. This is what is the surface area is given by. So let's say the original surface area is 4 pi r square. Then he says the radius is increased by 2. So the new radius become r plus 2. So the new surface area becomes 4 pi into r plus 2 whole square. So this is the new surface area. This is the older surface area. What he wants us to calculate, he says that the new surface area is increased by 352 than the older surface area. So clearly we can equate them. So it has to be 4 pi r plus 2 whole square is actually with the increment of 352 in the original surface area, that was 4 pi r square. Now we can make an equation out of this and then solve. So it has to be 4 pi into r plus 2 whole square will be opened by a plus b whole square is going to be r square plus 4 plus 2 into 2r, that is going to be 4r, is equal to 352 plus 4 pi r square. If we solve this further, this becomes 4 pi r square plus 16 pi r is equal to 352 plus 4 pi r square. If we solve this further, 4 pi r square and 4 pi r square get cancelled. We are left out with 16 pi plus 16 pi r is equal to 352. If we put the value of pi, we are ultimately getting the r plus 1 value is equal to 352 into 7 divided by 16 into 22, which is coming as 7. So clearly R value comes out to be 6 centimeters. That's what he had asked for. Find the radius of the original sphere. That is nothing but 6 centimeter. Now he says the surface area of a cuboid is 22 centimeter square and sum of the length of all of its edges is 24 centimeter. So since it is a cuboid, it will have to deal in length, breadth and height, all different. So he says the surface area is 22 centimeter square. So what is the surface area of a cuboid? Surface area of a cuboid is given by, because a cuboid is given by twice of LB plus BH plus HL. Okay, and this value is given out to be 22 as in the question. So clearly, and one more thing that he has given to us is that sum of the length of all its edges, the sum of the length is nothing but 4 times L plus B plus H, because a cuboid has got uh, the cuboid has got L plus B plus H, and everything is just repeated 4 times. So it has to be 4 plus L plus B plus H. That is the sum of the length of all the edges of a cuboid. That is it being given as 24 centimeter, which gives us L plus B plus H value as just 6 centimeter. So these are the two things that we have got, L plus B plus H and 2LB plus BH plus HL. Now what he wants us to calculate, he wants us to calculate the length of the diagonal of a cuboid. Length of the diagonal of a cuboid is always given by L square plus B square plus H square. So we need to find out L square plus B square plus H square in terms of these two things, L plus B plus H and 2LB plus BH plus HL. Let us find out some formula so that we can directly do it. So clearly there is a formula which can connect. L square plus B square plus H square is given by L plus B plus H whole square minus twice of LB plus BH plus HL. So if we use this particular formula, then we can obviously equate. Let us try to find out L square plus B square plus H square is going to be, we have got the value of L plus B plus H, that is 6 square, minus 2 twice of LB plus BH plus HL value is already given to us 22. So this comes out to be 36 minus 22, that is 14. That is the value of L square plus B square plus H square. Diagonal has to be under root of this, so it has to be under root of 14, which is nothing but 3.74 centimeter precisely. So that is the right answer, 3.74 centimeter, available in option number C. Then he says radius of the cylinder is half of its height and area of the inner part is 616 centimeter cube. So let us understand. He says the radius is half of the height. So r is equal to h by 2, or we can write h value as 2r. Then he says area of the inner part. So area of the inner part of a cylinder includes the area of the base, that is pi r square, plus area of the walls. So that has to be area, or let's say the inner area of a cylinder is given by, the cylinder is always given by area of the inner base, that is circular in shape, plus the area of the walls, that is 2 pi rh. Okay, so let us replace rh as 2r in this. So this can be written as, if we take pi r common, this can be written as r plus 2h. Okay, and this value is given to us as 616. So let us equate this to 616. Okay, let us put down the values of h. So it becomes pi r into r plus 2 into 2r is equal to 616. We can generate an equation in terms of r. So it becomes pi into 5r square is equal to 616, which gives the r square value as 196 by 5, which gives a r value as 14 by root 5 centimeters. So that is the value of the radius. He wants us to calculate the volume. For finding out the volume of the cylinder, we need to know the radius and height both. Radius is already come, so we need to find out the height. Height was nothing but, as equated here, height was 2r, so height was 2 into 14 by root 5, that is nothing but 28 by root 5. That was the height in centimeters. Now we are supposed to find out the volume. Volume of a particular cylinder is given by pi r square h. Let us put down the values. So it has to be 22 by 7 into r value is 14 by root 5 whole square into h value as 28 by root 5. So if we solve this further, this particular volume comes out to be 1538 centimeter cube. 1538 centimeter cube. It is available in option number B becomes the right answer. Then he says, three cubes with sides 3 is to 4 is to 5 are melted to form a single cube whose diagonal is 12 root 3 centimeters. So let's say the sides are 3 is to 4 is to 5. So let's assume the sides to be 3x, 4x, and 5x. These are the sides of three different cubes. So, and their volume is collectively melted. So first of all, we need to calculate the total of that volume. So total of that volume of a cube is given by side cube. Okay, we have got three different sides. So volume of these three cones all together will be first side cube plus second side whole cube plus the third side's whole cube, 5x whole cube. This will be the sum of all the volumes together. Let us do it. So this is going to be 27x cube plus 64x cube plus your 125x cube. Okay, if we add it together, this is going to be ultimately 216x cube. Okay, this much is the total volume that will be created. Okay, then he says this has, so this is the ultimate volume of the uh, the single cube that is to be formed. Now the diagonal of the single cube is given. Diagonal of a single cube is given as 12 root 3, but diagonal of a cube is given by side root 3, is given by side root 3. So clearly, if we compare these two things, side of this single cube is coming out to be simply 12 centimeter. Okay, side of this volume, this particular single cube is coming out to be 12 centimeter. Now, clearly we need to find out that we need to find out the volume of this particular single cube, and we can make it equal to the volume that we have created from using the x. So volume of this cube will be simply 12 cube, and this will be equal to the volume that we created, that was 216 x cube. So clearly we need to solve this particular equation for finding out the x. So clearly x is given by 12 into 12 into 12 divided by 216, that is nothing but x comes out to be value called as 2. X comes out to be value called as 2. Now he wants us to calculate the sides of the cube. With x equal to 2, we can calculate all the sides. Okay, so the first side becomes 2 into 3, that is 6, that is 6 centimeter. Another side becomes 4 into 2, that is 8 centimeter, and the last one becomes 5 into 2, that is 10 centimeter. So these are the three sides available. Let's see where it is. 6, 8, and 10. It is available in option number A, so it becomes the right answer there. Then he says the height of a wall is 6 times of its width, and the length of the wall is 7 times its height. So let's keep on using these connections. So there is a wall. So obviously the wall is of a cuboid shape where the LBH is separate. So he says height of the wall is 6 times the breadth. So we can say height is 6 times the breadth or the width. Then the next thing he says, so we can write B as h by 6 for this. Then the next thing he says, length of the ball is 7 times the height. So length is equal to 7 times the height. So now we have everything. We have all the dimension L, B, and H converted in the form of H itself. Okay. Now we can find out the volume of this particular wall. Okay. So he says the volume of the wall is 16128 meter cube. So let's say the volume of this cuboidal shaped wall is L into B into H. L value is 7H. B value is h by 6, and h is as it is h is equal to 16128. So we need to solve this and find out the h value. Okay, if we do that, the h cube is coming out to be 16128 into 6 divided by 7, which gives us the h value as cube root of 13284. If you solve this cube root, it comes out to be 24 meters. So that is the height of the uh, particular wall is, but he is asking for the breadth. So there is a connection between height and breadth. That breadth is given by height divided by 6. So it has to be 24 divided by 6, which is nothing but 4 meters. So that is the value of the breadth, 4 meter. It is available in option number B. Now he says, if three cubes are placed adjacently in a row, then find the ratio of the total surface area of the new cuboid to that the sum of the surface area of the three cubes. So these are the three cubes that have been joined together like this, 1, 2, and 3. These are the frontal surfaces, and this is how the cubes are. This is how they look to be. Okay, so this is how they have been joined. Now he's saying these are joined adjacently in a row. Find the ratio of total surface area. Okay, let's say the dimension, let us say the side or the edges of all these cubes is a in all the dimensions, in a in all the dimensions. So clearly we can say the total length of the combined figure is 3a, total breadth of the combined figure is a, and total height of the combined figure is only a. Okay, so we can use this to find it out. Now, first of all, let us find out the total surface area of the new cuboid. Total surface area of the new cuboid that has been made by joining them. So always total surface area is given by 2 into LB, is always given by 2 into LB plus BH plus HL. Okay, so length of the new cuboid is as seen in the figure is 3a, breadth is a, and height is also a. So let's put down the value. So it's going to be 3a into a plus a into a plus a into 3a, LB plus BH plus HL, which comes out to be 14a square. It actually becomes the 14a square. Now let us see the total surface area of the cube separately. So each cube had got a surface area of a square. Okay, so three cubes have got the total surface area of three cubes separately is nothing but thrice of a square. Now he wants us to calculate the ratio. So the ratio will be simply 14a square by, rather, 3 into 6a square. This has to be 3 into 6a square, that is nothing but 18a square. Okay, because each cube has got a surface area of 6a square, and there are three such cubes, so it has to be 3 into 6a square, that is 18a square. So the ratio will be 14a square by 18a square, which is nothing but 14 is to 18, which can be simplified as 7 is to 9. So that is the right answer, 7 is to 9, option number D. Now it says the diameter of the ends of a dustbin 24 centimeter high, which is in the shape of a frustum of a cone, are 30 centimeter and 10 centimeters. So let's create the shape of a frustum. How does a frustum look like? This is how the frustum look like, where there is a small diameter and there is a bigger diameter. There is obviously height and slant height involved. Now he says the diameter of the ends of a dustbin are 24 centimeter high. So that means the height value is given to us as 24 centimeter. Okay, which is in the shape of frustum of a cone are 30 centimeter and 10 centimeters. So clearly the bigger diameter is 30 centimeter. So the radius becomes 15. Radius becomes 15, and the smaller diameter is 10 centimeters. So radius becomes 5 for this one. Okay, determine its capacity and its surface area. Determine its capacity and surface area. Okay, so let us try to find it out. So for finding out the capacity, first of all we have to find out the slant area, slant height. So slant height of a frustum is given as L is equal to under root of h square plus r minus small r whole square. Okay, where this capital R is nothing but the larger radius, the small r is nothing but the smallest radius. Okay, so let's put down the value. The slant height is given as under root of 24 square plus capital R value is 15, small r value is 5. 15 minus 5 whole square. If you solve this further, this comes out to be root 576 plus 15 minus 5, 10, 10 square is hundreds, plus, so it's equal to root of 676. Okay, this root of 676, and which is nothing but 26 centimeters. So the length of the slant height of this frustum, which is in the shape of this, is 26 centimeter. First of all, this is calculated. Now, he asked for the determine its capacity. Capacity is nothing but the volume it has. Capacity of any object is nothing but the volume of that object. So we need to know the volume of the frustum shaped objects first. Volume of the frustum shaped object. So the formula for that is pi h divided by 3 capital R square plus small r square plus r into r. This is the formula for the volume of a frustum is. Okay, so we have got all the values. So let us keep the values inside and find out the capacity. Capacity, that is going to be pi is 22 by 7 into height value is 24 divided by 3. Okay, multiplied by inside there is 15 square, the capital, the larger radius plus small r, that is 5 square, the smaller radius square, plus capital R into small r value. So if we solve this further, this is coming out to be 22 by 7 into 8 into 15 square is 225. So it's going to be 225 plus 25 plus 15 into 5 is going to be 75. So let us just solve it. This comes out to be ultimately 57,200 divided by 7, that is 8171.43 centimeter cube. So that is the actual volume or the capacity of the frustum shaped dustbin is. So now let us find the next part of the question. He asks surface area. So we need to know the formula of surface area for that. So we can write surface area of a frustum is given by, frustum shaped any object is always given by pi into capital R square plus small r square plus L into capital R plus small r. This is the particular formula for your frustum shaped any object. This is the particular formula. So let's put down the values inside. So it's going to be 22 by 7. Capital R is 15 square. Small r is 5 square. Plus length value, the slant height we just calculated was 26. Then capital R is 15. Small r is 5. So let us just solve it. This is going to be 22 by 7 into 15 square is 225 plus 25 plus 26 times 15 plus 5 is 20. So this is what we have to calculate. This ultimately comes out to be 22 by 7 into 770. That is nothing but 2420 centimeter square. So that is the surface area of the frustum. So we have got two values, 8171.43 and 2420. Let's see where it is available. It is available in the option called as D. So that becomes the right answer. Now he says the surface area of a sphere is same as the curved surface area of a right circular cylinder. So surface area of the sphere has to be made equal to, so surface area of the sphere is nothing but pi r square. That is the surface area of the sphere. He's saying this is equal to surface area of the surface area. Let's say it is of surface area of a sphere. So let's apply a S symbol here. Then he says this is equal to the curved surface area of a right circular cylinder. So let us understand what is the surface area of the right circular cylinder is. That is nothing but 2 pi RC into HC. We have written RC and HC so that it can be understood that this is the dimensions of a cylinder. Now let's just put down the values. He has already given the radius and the height of the cylinder, that is diameter is given as 12, so radius will be treated as 12 by 2 6, and and radius and height and diameter both are 12, so height value is also 12 and radius value is 6. So let us apply the values here. So pi into radius of the sphere square is equal to 2 into pi into RC value is 6 and height value is 12, so it is 12. So if we solve this further, this pi and pi gets cancelled, so we are getting RS square is value as 2 into 6 into 12, that is nothing but 36. Okay, so here the RS can be calculated as root of 36, that is nothing but 6 centimeters. So that is the radius of the sphere that has come out to be, and it is available in option number C. So it becomes the right answer there. Now he says the base diameter of a conical tomb is 28 meter and its slant height is 50 meter. Okay, so conical tomb always has got a base of a in the shape of a circle. So he says the base of a diameter of a conical tomb is 28 meter. So diameter of that particular base is given out to be 28 meter. That means the radius will be simply 14 meter, and this is how the cone will go. And its slant height, so this particular slant height of this particular cone is given as 50 meter. He's saying the find the cost of whitewashing the curved surface area at the rate of 80 paise per square meter. So we need to first find out the curved surface area, then when we can multiply that CSA with the rate. Okay, so let us see the curved surface area of the cone. That is nothing but pi RH, that is the curved surface area of the cone is. So we have got the value of R and H also 22 by 7. Radius value is given out to us as 14, that is 28 by 2, and slant height, rather this is pi RL, not pi RH, this is pi RL, and the slant height given to us is nothing but 50. So let us put down the values and solve. So 7 can cut this 14 by 2. 22 into 2 is 44 into 50. This is what we have to solve, which comes out to be ultimately 2 lakh 22,000 meters square. That is the curved surface area that is to be whitewashed. Now, what is the rate of whitewashing? He says 1 meter square is to be, the rate of 1 meter square is 80 paise, that is 80 by 100 rupees. 80 by 100 rupees because 1 rupees has got 100 paisa. So we have to whitewash 22,000 meter square. So that is going to be 80 by 100 multiplied by 22,000. So if we calculate, these two zeros get cancelled. So it ultimately comes out to be rupees 1,760. So that is the right answer. 1,760. Now he says if the volume of the cube is 512 centimeter cube, finds its total surface area. So clearly we are supposed to find out the side of this cube first, and then using that we can find out the total surface area. Okay. So volume of the cube is given as 512 centimeter cube. The formula for the volume of the cube is nothing but side cube. Side cube value is 512. So what is the value of the side? The value of the side is cube root of 512. Okay, and clearly the cube root of 512 is nothing but 8. So now we can find out the total surface area. Total surface area can be calculated by 6 into a square. So let us put that value. 6 into side value is 8. 8 square we have to do. So it's going to be 6 into 64. That is nothing but 384 centimeter square. So that is the total surface area of the cube is 384 centimeter square. He says the volume of the cuboid is twice that of a cube. So volume of the cuboid is twice that of a cube. If the dimension of the cuboid or L is 9, breadth is 8 and H is 6. L is 9, breadth is 8 and the height is 6. Then find the total surface area of the cube. Okay. So let us find out the volume of the cuboid. He says volume of the cuboid is equal to twice the volume of the cube. So we need to find out the volume of the cuboid first. Volume of a cuboid is given by L into B into H always. So we have got all the values. So it is 9 into 8 into 6 is equal to twice the volume of the cube. Okay, so we can easily find out the volume of cube by this way. So volume of a cube by this way comes out to be 9 into 8 into 6 is 432. So it comes out to be 432 by 2. That is nothing but 216 centimeter cube. So that is the volume of the cube. He wants us to calculate the total surface area of the cube. So for that, we need to find out the side of the cube. So side can be found out by cube root of the volume of the cube. So side of the cube comes out to be cube root of volume of the cube is 216. So 216 cube root is nothing but our 6. So side of the particular cube is come out to be 6 centimeter. We need to find out the total surface area of the cube, which is given by 6 a square, which is given by 6a square. So let us find it out. 6 into side is again come out to be 6. So 6 into 6 square, that is nothing but 6 into 36, which comes out to be 216 centimeter square. So that becomes the right answer. That is available in option number C. Now, the question says 50 men took a dip in a water tank 40-meter long, 20-meter broad in a religious day. So that's goes the tank like this. So it's 40-meter long, 20-meter deep, 20-meter breadth, and there was water in this particular pond. Okay, so they took a dip, so obviously the water would have risen. Okay, so let's say the water is risen till this particular height. Earlier it was here, now the water has risen to this particular point. Okay, the water has risen to this particular point. He says the average displacement of water by a man is 4-meter cube. How much water does one man displaces? The water displaced by one man is 4-meter cube. So how many men do we have? We have 50 men. So total displaced water when they dip into it, the total displaced water is going to be clearly number of men is 50 multiplied by volume displaced by one man is 4. So it's going to be 200 meter cube. Okay, this is the total displaced water, and obviously this total displaced water will be because of the total displaced water is because of the man in there. So that the total displaced water will actually be increasing the height of the water in the pond. So clearly the volume that has risen in the pond will be equal to the total volume that has been displaced by the man. So volume risen, we'll write like this: volume of the water risen in the tank will be actually equal to 200 meter cube. That is the volume displaced by the man. Okay, so let us find out the volume risen in the tank. So volume risen in the tank will be in the shape of the tank itself. Okay, that is a cuboid. So whose length is given as 40, whose breadth is given as 20, and the height we are supposed to find out, that will be the volume risen, is equal to 200 meter cube. So if we solve this further, we can calculate the h value. So h value, so 0 and zeros are gone, so 2 can be cancelled. So H value is ultimately coming out to be 1 by 4 of a meter. All the options are given in centimeter. So we also have to convert it into centimeter. 1 meter has got 100 centimeters. So it's coming out to be 1 by 4 into 100. That is nothing but 25 centimeters. So that is the final answer. Option called C is the right answer.